to use the division algorithm to change 1, 2, 3, 4 base 10 number into a base 7 number. So dividing 7 into 1, 2, 3, 4 goes 176 times with a remainder of 2, which means 1, 2, 3, 4 can be written as 7 times 176 plus 2. Dividing by 7 again, 7 into 176 goes 25 times remainder 1. So we can write 176 as 7 times 25 remainder 1. Dividing by 7 again, 7 into 25 goes 3 times remainder 4. So we can write 25 as 7 times 3 plus 4. Finally, dividing 7 into 3 goes no times remainder 3. So we can write that 3 is equal to 7 times 0 plus 3. All we need to do now is to read up the remainders, and that gives us our base 7 number. So reading up the way, 3, 4, 1, 2 in base 7 is our answer. Number 11, part A, we have to write down the derivative of sine inverse of x. So d by dx of sine inverse is 1 over the square root of 1 minus x squared. Part B, we have to use integration by parts to obtain the integral sine inverse of x over the square root of 1 minus x squared. Now first of all, we need to find the integral of x over the square root of 1 minus x squared. We can do this if we put the substitution u is equal to 1 minus x squared, because du will then be negative 2x dx. And that means that x dx will be negative a half du. The integral, the x dx in the top, is negative a half du, and the 1 over the square root of 1 minus x squared is 1 over the u to the half, which is u to the minus a half. So this is just the integral of minus a half u to the minus a half du. Adding 1 to the power is u to the plus a half divided by a half, multiplied by the negative a half. The half will cancel with the negative a half to give a negative 1. So that will be negative u to the half. Putting the u back in, that is negative 1 minus x squared to the half, which is negative the square root of 1 minus x squared. Now back to the integral of sine inverse of x times x over the square root of 1 minus x squared dx, and the reason why I did the first bit. So this is integration by parts, or definting. So I draw a definting table. We're going to differentiate the sine inverse of x, and we're going to integrate the x over the square root of 1 minus x squared, which is what I just did up here. Differentiating sine inverse is 1 over the square root of 1 minus x squared. Integrating the x over the square root of 1 minus x squared, that gives us negative the square root of 1 minus x squared. Split this into the 4 bits, 1, 2, 3 and 4. So that the integration by parts formula tells us to work out 2 times 4 minus the integral of 3 times 4. Position 2 is sine inverse of x times in position 4 negative the square root of 1 minus x squared. So when we multiply them together, we get a negative sine inverse of x times the square root of 1 minus x squared. Subtracting from this is the integral of 1 over the square root of 1 minus x squared times negative the square root of 1 minus x squared. So that's negative sine inverse of x times the square root of 1 minus x squared. When we multiply these together and apply the negative sign from outside, we see that this is just plus the integral of 1. So that's negative sine inverse of x times the square root of 1 minus x squared. Integrating 1 with respect to x just gives us x plus c. So that's the answer to our integration. In this question we're told that the radius of a cylindrical column of liquid is decreasing at the rate of 0.02 meters per second. Because it's decreasing, this will be negative. So that will be dr by dt is equal to negative 0.02. While the height is increasing at the rate of 0.01. Because it's increasing, that will be positive. So dh by dt will be 0.01. We are asked to find the rate of change of the volume when the radius is 0.6 and the height is 2. So r is equal to 0.6, h is equal to 2. We want to find the rate of change of the volume with respect to time, so that's dv by dt. We know that v is equal to pi r squared h, so if we differentiate implicitly and using the product rule, we'll be able to work out dv by dt. So dv by dt will be equal to, using the product rule, and this is our first function, pi r squared, and the h is our second function. Start off by differentiating pi r squared with respect to t. That will be 2 times pi times r times the r by dt. And we multiply this by the second function, the h, left as it is. So that's 2 pi r times the r by dt times h. Plus, we now leave the pi r squared as it is, differentiate the h with respect to t. The h will just be 1 times the h by dt. So that's pi r squared times 1 times the h by dt. We're now going to fit in values. We're going to put the h by dt is 0.01. The r by dt, negative 0.02. R is equal to 0.6 and h is equal to 2. So dv by dt is equal to 2 times pi times 0.6 times negative 0.02 times 2 plus pi r squared, so that's pi times 0.6 squared times 1 times the h by dt, which is 0.01. That gives us that dv by dt is negative 0.048 pi for the first part, plus 0.0036 pi. When we add them together, in terms of pi we get negative 0.0444 pi. Now if we fit a value of pi in for this, we get an approximate answer of negative 0.139 meters cubed per second, since it's a volume. And this is our answer.